I tried to make this a little bit better, but we'll see. So I have 45.16 minus 18 and 59 hundredths. I guess I shouldn't have done that. And so what this is called, this is the constant difference method. So when you have kind of a complex problem, because here we're going to have to start borrowing and carrying, and things can kind of get all out of whack, it's much better to think about the problem, make it friendly for yourself first before you do anything. So when we're doing subtraction, what we really want, we want to have a number down here that has zeros in it, because zeros are super easy to subtract. So looking at 18, what I see is we can get to 20 pretty quickly. We're just going to add, here, I'll do this in blue. I don't know if that's going to work or anything to show up at all. So I know I need to add 0.41 to get me to zeros, and that's going to get me to 19, and so that's just one more to get there. So that's going to take me to 20. Let's make sure I don't leave the screen here. And I'm going to have to add the same thing because we want to be constant. Remember, in addition, we do the opposite to each number. If we add to one number, we need to take away from another, but in subtraction, we want to keep those numbers the same distance apart because that's what we're trying to find out there. So we're going to add a 1.41 here, so that's going to take us to 46 and 57 hundredths. So now when we do the subtraction, look at that. It's just 0 minus 7, 0 minus 5, 0 minus 6, and 4 minus 2. So way more straightforward. And on a number line, what that looks like is when we start with 18 and 59 hundredths, and we have 45 and 16 hundredths. And we add that 1.41 to get us to 20. That's going to be the same distance. I'm sure that's not accurate. So this here, these two distances, is 20.57. So it's the same thing. We're just, again, making things a little friendlier on ourselves with that constant difference strategy.